Hello, welcome again. We are covering the subject thermodynamics for civil supplements, IFS and various gate exam. The next topic in the chapter of availability is quality of energy. To understand this topic, we'll consider a gas of mass m, specific heat Cp, entering the pipe at temperature Ta and exiting the pipe as Tb. It is losing heat continuously as it flows through the pipe. Okay, suppose at any infinite decimal space, suppose here the temperature drop is dt and average temperature is T, then heat lost would be mcp dt, or in terms of small change in entropy it is T into ds. So both are equal, so ds will be equal to mcp dt by T, or dt by ds is equal to T by mcp. So from this equation we can see that the slope of Ts diagram is directly proportional to temperature. Slope of Ts diagram is directly proportional to temperature. Higher the temperature, higher will the slope. So it means there would be lesser entropy change for same dt when the temperature is higher. Okay. So now we consider two sections, this section and this section. Here the average temperature is for T1 and here the average temperature is T2, and same heat is rejected from these two sections. Here the heat rejected is 2 and here it is also 2. So if we consider this section first, then Q will be equal to mcp T1 dash minus T1 double dash. So here the temperature drop in this section is from T1 dash to T1 double dash, and average temperature is your T1. Or this can also be expressed in terms of T1, that is T1 into del S1. Okay. So heat loss is your T1 into del S1 at location 1. So as this heat is lost, if this heat would not have been lost, then we can obtain some work from that heat. Okay. And the maximum work that we can obtain from this heat is your available energy. So it means some available energy is lost with this heat. So that available energy lost is W1, suppose, that is equal to this Q minus P naught into del S1 that we have studied. Okay. Same entropy change and taking atmospheric temperature, and this is Q. Okay. So now we consider this section, second section. Here the average temperature is T2 and temperature drop is taking from T2 dash to T2 double dash. Same thing now we can apply. So here the heat supplied is for same. So heat loss is for same, that is mcp T2 dash minus T2 double dash, or equal to T2 del S2. That is same as that of section 1. Okay. And now the availability lost will be also given by same formula, just replacing del S2 del S1 by del S2. Okay. So it will be W2 is equal to Q minus T naught del S2. So here we can see that this del S1 would be less than this del S2, because if we equate these two heats and T1 is higher than T2, so del S1 has to be lower than del S2. So it means this del S1 is lesser as compared to this del S2. So it means more available energy is lost here. So at higher temperature the loss in available energy is more. At higher temperature the loss in available energy is more. So it means we have higher quality at higher temperature. If we are losing heat, same heat at higher temperature and at lower temperature, so we are losing more work or more available energy at higher temperature. So it means the quality of energy is higher at higher temperature. Okay, because W1 is more than W2, or available energy is more at higher temperature as compared to lower temperature for the same heat loss. Okay, so it means we have to prevent this. For this we have to provide insulation at higher temperature, more insulation at higher temperature, or we think about uh, preventing loss at higher temperatures as compared to the lower temperatures. Okay, so this is your quality of energy, and from this we can drive the law of degradation of energy. So that is a law of as the temperature drops. So this is your higher temperature and this is your lower temperature. So here we can see that this is the entropy change for the same heat loss, and here this is the entropy change for the same heat loss. Here temperature is lower, so T2 into del S2 will be equal to T1 into del S1. As T1 is higher, so this del S1 will be lower. Okay, but here the unavailable energy is your T naught into del S1. Okay, and here the unavailable energy is your T naught into del S2, or T naught into del S2, or T naught into del S1. So as we can see that for the here we have more unavailability as compared to this, because del S1 is lower than del S2. So here already more unavailability there, so this availability is more here. If this energy is lost, then we have lost uh, more available work. So this is your law of degradation of energy. So heat at higher temperature is more useful as compared to same heat at lower temperature.